Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we are completing our lesson, section 2, characteristics of waves, page 518 to 525. In this part, we stopped at wave speed. We learned about wave length and period, frequency, and amplitude. What is wave speed? Wave speed equal to wave length divided by period. Why? Because speed is distance divided by time. Wave speed, this is the distance, and the time period. So wavelength divided by time, this is equal wave speed. But as we know, period is the inverse of frequency. So wave speed equals frequency times wavelength, because frequency equal inverse period. So the wave speed equals frequency multiplied by wavelength or times wavelength. This is the equation that we will use to get speed of a wave. So the equation for the speed of a wave equal to V, this is speed, meter per second, F, frequency, and wavelength. So V equal frequency multiplied by wavelength. Let's practice. You have the practice in your book, page 519. The string of a piano that produces the note middle C vibrates with a frequency of 262 Hz. If the sound waves produced by this string have a wavelength in air of 1.3 meters, what is the speed of the sound wave? As we learned before, we should write the given and the unknown values first. Given frequency 262 Hz, wavelength equal to 1.3 meters, and the unknown wave speed. As we learned, the wave equation is V speed equal to frequency multiplied by wavelength. We will put the values, means V equal to frequency 262 multiplied by wavelength, which is 1.3, and we will get the result V, the wave speed equal to 341 meter per second. The speed of a wave depends on the medium, not on the frequency. In general, wave speed is greatest in solids and least in gases. And in a given medium, in a specific medium, solid or liquid or gas, the speed of the wave is constant, even the frequency changes. How we differentiate between or how we explain that there is difference in wave speed? This is depend on the medium because of the particles arrangement. In gases, for example, who can tell me? Yes, particles are far apart from each other. So waves take time to travel through gases because particles take time to, the vibration take time to move from one particle to another. So waves travel the slowest in gases. In liquids, particles are closer than in gases, so the waves travel faster. In solids, particles are tightly close to each other. This means the wave will travel very fast, the fastest in solids. About light speed. Light has a finite speed or specific speed, fixed one. Light doesn't take time to travel from one place to another because light is electromagnetic wave, which can travel in empty space. All electromagnetic waves in empty space, they travel at the same speed, which known as speed of light. So speed of light is a fixed amount, fixed number, constant. We give it the symbol c. This is speed of light, which equals to 3 times 10 power 8 meter per second. Speed of electromagnetic wave as any speed equal frequency multiplied by wavelength. Check the picture here. You have the same in your book. Light travels more slowly when it has to pass through medium such as air or water. Look at the picture. Our eye can detect light with frequencies ranging from 4.3 to 7.5 times 10 power 4. The frequency higher than this, invisible for us. Frequencies which lower than this range is also invisible for us. Light in the range here called visible light. Visible light is a part of the electromagnetic spectrum. Inshallah, we will explain electromagnetic spectrum in the coming lessons. What is pitch or sound pitch? It is how high or low a sound is. The sound pitch determined by the frequency at which the sound wave hits your eardrum in your ear. So how high or low a sound is determined by frequency. Higher pitched sound caused by sound waves which has high frequency, and also low pitch sound caused by waves which has low frequency. Look at the picture here. Low pitch sound means low frequency, few waves per second. High pitch sound, high frequency, and this means more cycles per second. Last part in our lesson is about Doppler effect. What is Doppler effect? Now let me ask you, why does the pitch of an ambulance change as the ambulance rushes past you? The siren of the ambulance. Because the motion between the source of waves and the observer creates a change in frequency. So the pitch will change, the pitch of the sound, because pitch depends on frequency changes when the source of waves is moving. This is what we call it the Doppler effect. So Doppler effect means when the source of wave is moving, there will be a change in frequency. Doppler effect happen in many types of waves, including sound waves and light waves. Look at the picture here. I think you have the same picture in your book. Here, the car is not moving. Sound waves have a constant frequency. But when the source of sound started to move, when the car started to move, the frequency changed from low frequency waves to high frequency waves, means from low pitch to high pitch. So when the car is coming in front of you, the pitch will increase more and more. You will hear the sound very high when it is near you and very low when it is far from you. We finished our lesson. Thank you for listening. Please read the lesson carefully and do your homework if you have.